Good morning, dear students. In our previous lecture, we have talked about oxidation number or oxidation state. And there I have told you one thing, that the maximum oxidation state which can be exhibited by any atom is always equals to its group number. Like, if we talk about sulfur, then sulfur belongs to group 16 or 6A. In sulfur, the number of valence electrons are 6, which can take part in bond formation. So for sulfur, the maximum oxidation state which can be possible is +6. Sulfur cannot show oxidation state of more than 6 because in the valence shell, sulfur is having only 6 electrons. Then the next point, osmium is the only element which is exhibiting oxidation state of +8. And this state is exhibited in OSO4, which is called osmium tetroxide. No other element can exhibit oxidation state of +8. If it is exhibiting +8 state, then the compound is not stable. So osmium is the only element or metal which can exhibit maximum oxidation state of +8. +8 state is not possible for any other element. So let us solve some more examples. So here, number first is CrO5, chromium pentoxide. We have to calculate the oxidation state for chromium in CrO5, which is called chromium pentoxide. You know it very well that if a neutral molecule is given or simply a molecule is given, then the algebraic sum of the oxidation state of all the atoms will be equals to 0. Or in other words, we can say that total positive oxidation state is always equals to total negative oxidation state. That's why charge up here is 0 and molecule is neutral. So here for chromium we have to find, so put X for chromium. There are 5 atoms of oxygen. So it is 5 into -2 equals to 0, gives you X minus 10 equals to 0. So X is equals to +10. So if we are solving for chromium in CrO5, then we are getting value of oxidation state as +10. Which is not possible. Why it's not possible? Because I have told you osmium is the only element which can exhibit maximum oxidation state of +8. No other atom or element or matter can exhibit oxidation state of +8. It means something is wrong here. Or if we want to get the exact oxidation state for chromium, then we have to see the structure for chromium. We have to see the structure for CrO5. CrO5 is having butterfly shape, or it is a butterfly shaped compound or a molecule. Now, remember one point. Oxygen in most of the compounds or the molecule exhibit oxidation state of -2. It is called oxide. Oxygen can also exhibit oxidation state of -1 when it is forming peroxide linkage or peroxy bond. whenever oxygen atom is forming a single bond with another oxygen atom, then this bond is called peroxide bond or peroxy linkage. And whenever oxygen atom is involved in peroxy linkage, then oxygen atom exhibit oxidation state of -1. So if it is oxide, oxygen will exhibit -2 state. And if it is peroxide, then oxygen will exhibit oxidation state of -1. So here concept of peroxide linkage is involved in the structure of CrO5. So here just take, there are 4 oxygen atoms which are involved in peroxide bond or peroxy linkage. Oxygen is forming single bond with another oxygen atom. Oxygen is forming single bond with another oxygen atom. So all the 4 oxygen atoms will exhibit OS of -1, -1, -1, -1. And the last oxygen atom, the 5th oxygen atom, which is not forming peroxy linkage, which is directly attached with chromium atom by a double bond, will exhibit oxidation state of -2. So out of 5, 4 are involved in peroxy linkage or peroxide bond, while the last one is involved in oxide bond. So how to calculate? Put X for chromium atom. There are 4 atoms of oxygen which is forming peroxy linkage, so put -1 for the 4 oxygen atom which is showing -1 oxidation state, and for the last one it is -2. So it becomes x minus 4 minus 2 equals to 0. So x minus 6 equal to 0. So x will be equals to plus 6. So in CrO5, chromium exhibit oxidation state of plus 6. That is possible. That is possible. Now the second one, Fe3O4, magnetite. If we solve it for Fe, then it can be solved as 3x, because 3 atoms of Fe is there and OS of Fe is not known. So we have to calculate. So 3x for 3 atoms of Fe plus 4 into -2 equals to 0. It becomes 3x minus 8 equals to 0. 3x equals to 8. 3x equals to 8. So x will be equals to 8 by 3. It gives you 2.66. So in Fe3O4, oxidation state for Fe is getting value as 2.66. It means fractional oxidation number it is getting, which is not possible because electrons cannot be transferred in fraction. It can be 1 electron, it can be 2 electron, it can be 3, it can be 4, it can be 5, it can be 6, it can be 7, it can be 8, but it cannot be 2.66. So why we are getting value as 2.66 for Fe? It's very simple. This is the average oxidation state of Fe in Fe3O4. Fe3O4 in reality is a mixture of FeO plus Fe2O3, ferrous oxide and ferric oxide, which is also called ferroso-ferric oxide. So when ferrous oxide is there, Fe will exhibit OS of +2, and when ferric oxide is there, it is +3. So this one is the average oxidation state of Fe in Fe3O4. But the real values are +2 and +3. Similarly, for third one, Ki3, we have to calculate OS for iodine. Potassium, it belongs to group 1 of phosphate. It is having only 1 electron in the valence shell. So all the alkali metals, that is sodium, potassium, rubidium, cesium, francium, gets oxidation state of +1. They are the metals. They are the electropositive elements. They have electron losing tendency. Because they are having only 1 electron in the valence shell, so they will be losing only 1 electron, as a result of which their OS will be +1. So 1 into 1 for potassium plus 3 into x for iodine equals to 0. When we solve for x, we will get value as -1 by 3. Again, we are getting fractional oxidation state for iodine. That is not possible. because electrons never transferred in fraction. They are transferred as a complete unit. Transfer of 1.5 electrons is not there. It is completely 1 or completely 2. So here this value represents average oxidation number for iodine. Then what's the real value? Ki3 is a mixture of Ki plus I2, potassium iodide and free iodine. So when Ki is there, I will exhibit -1 state, and when I2 is there, each iodine atom will exhibit 0 oxygen state, because this is the free state for iodine. So all the atoms when present in free state exhibit OS of 0. There is no transfer of electron. Then comes number 4, H2SO5, which is called Carrot's acid or peroxomonosulfuric acid. Let us calculate for sulfur. Hydrogen belongs to group 1. In most of the cases, it exhibits +1 state. But when it combines with metals, when it forms hydride, then in that case, hydrogen exhibits OS of -1. And if metal is not there, then OS is always +1. So here 2 into +1 for 2 atoms of hydrogen, and for sulfur it is X, because we have to calculate for sulfur, plus 5 into -2 for 5 atoms of oxygen equals to 0, gives you 2 plus X minus n equal to 0, X minus 8 equal to 0, so X will be equals to 8. That is not correct, incorrect. Sulfur never exhibit +8 oxidation state because it is a member of group 16 or 6A. The total number of valence electron in sulfur is 6 only. Then how it can exhibit OS of +8? It's not possible. +6 is possible. All the 6 electrons can be transferred away from the sulfur. But +8 is not possible because 8 electrons are not available in valence shell of sulfur. Remember, these are the valence electrons which always participate in bond formation or compound formation. Innermost electron is having no role in chemical bond formation. So whatever the oxygen state we are getting is always due to valence shell electrons, not due to innermost electrons. It means something is there in the structure. So what is there? This is the structure for H2SO5, which is called Carrot's acid or peroxomonosulfuric acid. There are 2 atoms of oxygen which are involved in peroxy linkage or peroxide bond. Oxygen single bond oxygen is there. It means peroxide bond is there. So whenever oxygen is forming peroxy linkage, then oxygen atom exhibit OS of -1. So out of 5, there are 2 electrons, there are 2 atoms of oxygen which are exhibiting -1 oxidation state. The remaining 3 will exhibit -2 state. So in this manner we can calculate 2 into +1 for hydrogen, plus X for sulfur, plus 3 into -2 for 3 atoms of oxygen, first, second and third, where oxygen exhibiting -2 state, and for remaining 2 it is -1. So 2 into -1 equals to 0. When we solve it, 2 plus X minus 6 -2 equals to 0. We will get X minus 6 equal to 0. So X will be equals to +6. So in H2SO5, sulfur atom is exhibiting +6 oxidation state, which is possible. So that's all over in oxidation number or oxidation state. In next lecture, we will talk about oxidizing agent and reducing agent. Thank you and have a nice day.